Good morning, students. After completion of the first chapter, that is aldehydes and ketones, now we have to start the second chapter in organic chemistry, that is carboxylic acids. Carboxylic acids contain the functional group C double bond OH, COOH, which is known as carboxy group. Previously in the olden books it was written as carboxyl group. Both are okay. But under the new studies, the name have been changed to carboxy group. It was carboxyl group previously. Carboxylic acids contain the functional group COOH, which is known as carboxy group. Students, you have in the syllabus, first you have to study the first 5 members of the homologous series of carboxylic acids, particularly the IUPAC nomenclature. General name is formic acid, acetic acid, propanonic acid, butanonic acid, grutic acid. Like that, the name or general name is like that. We are not caring for that. We should go for the IUPAC nomenclature. The carboxylic acid generally in IUPAC nomenclature, it is mentioned as alkanoic acid. Alkanoic acid, ALKANOIC, alkanoic acid. And what are those examples? First is formic acid. Formic acid is written as methanoic acid. Methanoic acid, because it contains only one carbon atom. So formic acid, according to the IUPAC nomenclature, is known as methanoic acid. Similarly, acetic acid is known as ethanoic acid. Similarly, propanoic acid, butanoic acid, and pentanoic acid, according to the increasing number of carbon atoms. So if it is only one carbon, it is related to methane, so therefore it is methanoic acid. If it contains 2, then it is related to ethyl, then it is known as ethanoic acid. Propanoic acid, if it contains 3 carbon atoms, then it is propanoic acid. If it contains 4, then it is a butanoic acid. Butanoic acid. General name is alkanoic acid. You can mention like that according to IUPAC nomenclature. Generally, you can say general name is formic acid, acetic acid, butyric acid, right? Like that, the general name is given according to the previous user. That is, I will tell you the common name. The general name is formic acid, acetic acid, propanonic acid, not propanoic acid, propanonic acid, right? Butyric acid, valeric acid, like that. It is given in the previous studies. Common name, general name. Both are not so important now. Generally, we have to, everything we have to express by the usage of IUPAC nomenclature. So, after seeing this, nomenclature, we have to go for 2 methods of preparations. I will adjust the camera. Let me adjust the camera to the right side. There are 2 methods of preparations. First method, both are hydrolysis. There are many methods of preparation for carboxylic acids, but here it is given in the syllabus. They have mentioned only 2. One is the hydrolysis of cyanides, alkyl cyanides. Hydrolysis of alkyl cyanides. This one is hydrolysis of alkyl cyanides. An example I have written here, that is CH3, CH2, CN. In presence of acid or alkali, water molecule is adding to, water molecule is adding to it, and you are getting an acid, corresponding acid. If you are taking ethyl cyanide, you will be getting a carboxylic acid containing 3 carbon atoms. Carboxylic acid containing 3 carbon atoms is a propanoic acid. According to the IUPAC, propanoic acid. Suppose if it is in the case of general name, you have to say propanonic acid. Propanoic acid. Actually, this is propanoic acid or propanonic acid, whatever it may be. So, if you take the one example, acid hydrolysis or alkali hydrolysis. alkali acid hydrolysis or alkaline hydrolysis, in which two molecules of water molecules are adding and you are getting the corresponding acids. Generally you can say RCN. RCN can be converted into RCOOH with water in presence of acid. Acid means HCl or H2SO4 or alkali. Alkali means NaOH. What I meant? So the hydrolysis happens in presence of acid or alkali and you are getting corresponding acids. Similarly, the second reaction is the so-called hydrolysis of esters, which this is actually ester on hydrolysis. This is a reversible reaction actually. It is a reversible reaction which you have seen somewhere in your studies previously also. You take one ester. What are esters? Esters are compounds formed by the addition reaction in between an acid and an alcohol. Esterification reaction. Esterification reaction is the addition reaction in which when acid and alcohol can be combined together in presence of concentrated sulfuric acid forming an ester. But in this reaction we are taking the reverse of that reaction. We are taking an ester. An example I have written here, CH3COO, This ester we are going to hydrolyze with the help of acid or alkali, in which one molecule of water is adding and we are getting an acid here. So this is a royal method, you can see, very old method, in which the ester can be converted into corresponding acid. This is the reverse of esterification. You can see esterification. Esterification is what? Esterification is the reaction between acid and alcohol, primary alcohol. You are getting an ester. That's why I told you this is a reversible reaction. So these two reactions you have to study very seriously for the preparation sector of this particular chapter, because only two reactions have been given for the studies purpose. So both are hydrolysis. One is hydrolysis of cyanides, that is nitrates. Cyanides are also known as nitriles, nitrile, LES. Similarly, esters. The reaction can happen in presence of acid or alkali. Usually concentrated sulfuric acid, concentrated HCl, NaOH, KOH, they are all used as the hydrolyzing agents. So these reactions 1 and 2 you have to study according to this syllabus. And then I have to go for the physical properties of this. Physical properties, main physical property is solubility. Solubility of the the acids. Solubility of the acids can be explained by taking the what you can say, the hydrogen bonding. So due to hydrogen bonding, one hydrogen bonding, that is the first physical property is here, solubility. Here we can study the intermolecular hydrogen bonding. Intermolecular hydrogen bonding means RCOH, which can be attached to the oxygen of the water. So this is the intermolecular. So intermolecular with water, not intermolecular with water. So here this is the carboxylic acid can form a hydrogen bonding with a water molecule. Similarly, this can be expressed like this. This can be this oxygen, and this can be another molecule like this. So here also the OH, you can write the OH like this. So here also you can represent the hydrogen bonding. So hydrogen bonding between one molecule of acid to water and another molecule of acid. So this type of hydrogen bonding, because of this hydrogen bonding, the miscibility is higher, the solubility is higher for the lower carboxylic acid. So the high rate of solubility can be explained by the intermolecular hydrogen bonding between what molecule as well as the acid molecule. That is one of the physical properties. Another physical property is its high boiling point. High boiling point is also can be explained between two molecules of acid molecules. This is one acid molecule and this is another acid molecule. They have the what you can say capacity to have the hydrogen bonding between this oxygen and this OH, and here also you can see this is OH group and here also oxygen. So we can say high extent of hydrogen bondings can be explained between two acid molecules. So two more acid molecules. This is in between the acid molecules. This is not in between. This is with water molecules. Therefore, this is inter and this is intra actually. This is intra, INTR, intra molecular hydrogen bonding. So this is because of this dimerization, because two molecules are combined together to form a single bond, single unit. That is known as dimerization. Because of the dimerization, it will have more high boiling. More energy should be given to the to separate the molecule. That's why high boiling point is reported for the carboxylic acids. Okay, let us now see the resonance in the molecule. There are actually two ways of resonance reported. One is, I will show the camera again with the mode. This is actually the carboxylic acid. I think it is visible to you, and otherwise I will show you again by taking the camera towards the board. So this is RCOOH. This is what we can call it is a carboxylic acid. So this carboxylic acid contains C double bond OH. So the double bond in this double bond, you can report the shift of electron towards the oxygen. At the same time, some electrons, a pair of electrons can come to this side also. So the double bond can change into such a situation, RC polar situation, RCO minus OH, but this oxygen has carrying one positive charge. So this is one, roughly we can say this is a resonance in the carboxylic acid molecule. In the carboxylic acid molecule, carbon among the CO bond, the electronic shifting is taking place and electrons are moving, electron pairs are moving towards the oxygen and the oxygen is getting a negative charge. Similarly, and due to this oxygen is getting, here this oxygen is getting a positive charge also. So this is the resonance in the carboxylic acid molecule. But if you see these two molecules, these are not equal structures. What do you mean by resonance? Resonance means exhibition of same structure, different structures having same energy. Different structures having same energy. But here we can say this is a polar situation, here it is not like that. So these are not equivalent. These structures are not contributed much to the original carboxylic acid. That is the rate of resonance in this particular situation is not so important. So therefore, what we have to see is we have to explain the situation in the carboxylic acid in a different way. The carboxylic acid molecule I have written here. Once again, you can see here now. C double bond OH can be ionized into R C double bond O minus and H plus. That is this molecule. Let me take a break now. Okay. This molecule. This is RCOOH. This is carboxylic acid, and which can be converted into a carboxylate ion. That is RC double bond O minus plus one hydrogen H plus. So this ion RC double bond O, this minus is known as carboxylate ion. This carboxylate ion you have to take separately, and you have to explain the resonance of carboxylate ion. This is carboxylate ion. This can be expressed as this thing. See this molecule. Again, you have to see this molecule RC double bond oxygen CO minus. In the second molecule RCO minus C double bond. So the double bond is shifting in between carbon and oxygen. In place, the situation was like this. In this case, the situation is like this. Okay. So these are equivalent structures, and generally you can express the carboxylate ion like this. This is the carboxylate ion. So, in the case of carboxylate ion, the just one second. Resonance structures are equivalent structures having same energy. Therefore, the extent of hydrogen bonding in carboxylate ion is comparatively more than the extent of the resonance in the carboxylic acid. This you have to take into the consideration for the next properties of the reactions. So students, after a long time, we are again meeting together, and we are just explaining some of the points regarding to the carboxylic acid and all. And this chapter is also important chapter. They will be able. The first chapter is very important. Aldehydes and ketones are very important. We will be getting many. We have nearly 10 to 12 marks, 12 to 13 marks, even up to 15 marks you can get from that chapter. From this chapter also important, because you have to study the properties as well as the compounds which can be derived from the carboxylic acids, acid chlorides, acid anhydrides, like that. So this is also a big chapter, and due to your absence in college, due to the pandemic, we are forced to have these online classes again and again, and I think you are following the subject, and you have to see the online classes. Everybody should learn. More than some 60 to 70 people are there, and you are not completely watching the program, which I am getting from the reports from the what you can say, the YouTube. So therefore, you have to see the program continuously, and I mean one program and after another program, like a one-to-one program, and you have to study the things with the help of some textbook written by Indra and Chitwar or any other book, organic chemistry. Thank you for the patient hearing.